Assalamualaikum warahmatullahi wabarakatuh. I will present about my project simulation and problem solving of three-phase Y-connected generator. Before that, let me introduce myself. My name is Muhammad Nazrin Zamhuri, and my metric number is 191091061 from G2 classes RK23. Okay, for introductions, three-phase generator consists of three single-phase generators with voltage equals in magnitude but different in phase angle from the others by 120 degrees. Okay, this can be represented diagrammatically by both waveform that we can see phase 1, phase 2 and phase 3. Okay, in a three-phase 120-degree systems, only three wires are required to transmit the power that would otherwise require six wires. One half of the copper is required and the wire transmission losses will be half. The advantage of three-phase system is it's required fewer conductors as compared to the single-phase system. It also give continuous supply to the load. As we can see in this type of three-phase system. Okay, in three-phase system, they have two types of connections. There is Y and delta connections. For this project, it's only required for me to do for Y connections only. Y connections, also known as star connections, is required four wires in which there are three phase conductors and one neutral conductor. This type of connection is mainly used for long distance transmissions because it has a neutral point. The neutral point pass the unbalanced current to the earth and hence make the system balanced. For my projects, all load are in balanced conditions. Okay, as we can see, this one is for phase voltage in positive phase sequence, and this also for line voltage for in positive phase sequence. Okay, we just focus in for line voltage sequence. Okay, for EAB, the phase angle is considered as as 0 degree. Then for EBC is negative 120 degree, and ECA is considered as 120 degree or negative 240 degree. Okay, for objective is to becoming familiar with the operations of a three-phase generator and the magnitude and phase relationship connecting the three-phase voltage, and then be able to calculate the voltage and currents for a three-phase Y-to-Y connected generator and loads. Okay, and then understand the significance of the phase sequence for the generated voltage of a three-phase Y-connected. Lastly, understand how to calculate the real active power of Y-connected loads by using conventional and 2-watt meter method. Okay, for my methodology for this project, for first, uh, I must refer ESA version 3 to get power factor and frequency based on the line voltage given. Okay, for frequency, by referring this ESA, we find that it used 50 Hz to generate voltage in the three-phase system. Okay, after that, we draw the circuit of three-phase Y-connected generator using PSIM. After this, I will show the example of simulation that I have been done. Okay, then get the value of resistance and inductance of the load according to metric numbers. Okay, before we construct the circuits in the PSIM, we need to locate the actual value of the resistance. We must first convert from impedance value to its actual value of inductance and resistance value. Okay, then did a calculation to get the value of power at load, voltage and current, made a calculations, and then run the circuit simulation to get the measured value of power at load, voltage and currents. The value of the simulation and calculations will be compared and recorded in the database. Okay, the simulation considered success when the calculated value and the measured value show the same result. Okay, for simulation result, for red line voltage of generator, I got E line 275 kilovolt for my value. And for Y connections, we know that E line is equal to set3 E phase. And to find E phase, we must 275 kilovolt divided with set3. And I got that E phase is equal to 158.77 kilovolt. And for Y connections, we know that I line is same, equal with I phase. And the frequency that used is 50 Hz according to ESA version 3.1. And from metric number, my metric number is 191.091.061. For transmission loss, I got 61 plus J10 ohm. And for load, 91 plus J9 ohm. Before we construct a circuit, we must get the actual value of inductors. Okay, for transmission loss, okay, 61 just pick up the value for resistor value, and then for inductors we must calculate by using this formula, and I got 0.032 Henry, and for load just pick up 91 for resistor value, and then I calculate, I got 0.029 Henry for load inductor.
One is my full circuit for this type of Y connections. Okay, this is for transmission load and this for load. Transmission loss, this and this load. Okay, this is Y connections, and I put 158.77 kilovolt for this voltage, for phase voltage. Okay, I will simulate this circuit. Okay, I will show you the only line and load for this circuit. Okay, this is example for circuit for graph for simulation in line current and load voltage. This is a measurement value that I got from this simulation for line voltage, line A for line current, line A,
The
B,
value
and C.
calculation that I've got for line current, line AA, line BB, and line CC. These three line got same value, 1.0365 kilo ampere, but difference for phase angle because we know that it is in positive sequence for phase angle, and I got this kind of value for calculation value. Okay, for line current, during simulation I got 1.03113 kilo ampere, slightly different, little bit different, two decimal places. This one 65, and for line current I got 13. Okay, for voltage drop, for voltage load, for my calculations, I got 65.0531 kilovolt, and got I calculate that I got 40% of P drop at load A, B, and C. They have same value of voltage drop. This is the example of conventional 2 watt meter methods for calculations. Okay, We know that 2 watt meter can be employed to measure the power in a three-phase, three-wire star connected, either in balanced or unbalanced load. In 2 watt meter methods, the current coils of the watt meter are connected with any two lines, let's say like this, like this, for phase A and phase C, and the potential coil of each wattmeter is joined on the same line. That is, to calculate the line current, we must use the line voltage uh, to got the value of line current. Okay, from the previous, we just pick up before we convert to phase angle, we just take the original value of line voltage, that is 275 kilovolt, and then put in this formula, divide with to the Z load, and then both of this line, I got same value of line current, that is 3 kilo ampere, but difference in phase angle. Okay, for power formula, uh, we use this formula, V line times with I line times with cos, and then phase angle, just pick up the V line over I line, which means we must subtract between these two value. And for wattmeter number one, I got this value, 820.99 megawatt. And for simulation value, I got 895.63 megawatt, slightly difference from the simulation value. And for the same with the wattmeter number two, I got 480.84 megawatt. And for simulation value, I got 524.55 megawatt. Very difference. And for to find total power, we just add these two wattmeter value, and I got 1.302 gigawatt for total power. And for simulation, I got 1.420 gigawatt.
Okay, I will show you the simulation of 2 watt meter method. Okay, this is the example of 2 watt meter method circuit. Okay, the circuit is same like its previous circuit. Just change the value of voltage 275 kilovolt, and then remove the value of transmission loss. And okay, this is the example of the connections for 2 watt meter method. Just take the ammeter and voltmeter, just stepping from uh, phase A to the phase B and phase C to the phase B. Okay, we just want to run the simulation to see the value of line current. Hello. Okay. Okay, this is the value of line current that I got from line AA and line CC. Slightly same with the value of the current for the calculations that I've got. Same. Okay.
Okay, lastly, as from this project, I can conclude that student has been managed to determine the phase sequence of three-phase supply and managed to identify the waveform. Next, determine the relationship between line and phase voltage as well as current for Y-connected generator. And lastly, be able to evaluate the parameter of electrical system based on Malaysia Authority Standard (ESA). I refer for version 3, also help us to find the real value of inductance value that allocate at the load line and transmission loss. Okay, that is for my presentation for this project. Thank you.